For this lesson, I want to discuss linear inequalities, and I'll use the same examples that we did in the previous lesson. So I'm going to graph f of x equals x minus 2 and g of x equals negative 1/2 x plus 4. So we know what those graphs look like. So I'll start with f of x. I'll put a couple of points up here. And okay, the graph looks like this. And I'll label it f of x. For g of x, that one again started at 4, had a slope of negative 1/2, and then I can draw the line going through those. Again, just a good enough sketch. I'll label this g of x. The goal of this example is to figure out where is f of x not just equal, but less than or equal to g of x. And we know part of the question already. We know where they're equal. That's this spot right here at x is equal to 4. So 4 is part of the solution. If you take 4 and you put it in place of x, you get that the left side is equal to the right side. But we also want to find all of the places where f of x is less than g of x. So what this means is, where's the y value of this graph, f, lower than the y value of this graph, g? So we can look at the picture to figure this out. What I'll do is compare several y values between f and g. So we know one where they're equal, but let's say we choose this y value compared to this one. I don't really even care what the y value is, but what I do know is that the y value of f is lower than the y value of g. So we definitely want to include the x value for this spot, which is 2. The same thing happens for this spot here and here. The y value of g is above the y value of f. So I'd like to include 3 as well. I'll pick a couple of others, like if I choose this spot. Okay, for this value of x, negative 2, f of x is definitely lower than g of x. If now I look, let's say here at 10, if I compare this spot to this spot, well, now it doesn't work anymore. So here I have that f of x is above where g of x is. So this does not make the inequality true. So what does this all mean? I'm going to highlight all of the x values that work for the inequality on the x-axis. So they start at 4, and they're all moving in this direction. These are all of the x values for which the inequality is true. So I'll jot that down as from negative infinity up to and including 4. For any x value that you choose within this interval, it's always true that f of x is lower than g of x. If you were on the other side, well, now all of a sudden you have that f of x is greater than g of x, so I would not want to include any of those. For example 2, I want to solve the same inequality that we had in example 1. I just like to do it this time without using a graph. And the good news is we can use all of the rules we have for working with an equation to solve this for x. And there's just one thing to watch out for. If you multiply or divide both sides by a negative number, it will change the direction of the inequality. So I stated the rule to the right here, but let's actually see if it'll come up in this example. So I'm kind of pretending that it's just an equal sign, even though I know I'm solving for probably a whole interval of values. Let's see. I think I'm going to multiply both sides by 2. Again, that's going to cancel the fraction. If I multiply both sides by 2, I'm going to double every single term. I'll get 2x minus 4. Now, 2 is a positive number, so it is going to have no effect on the inequality, meaning it's still going to be less than or equal to. And on the other side, okay, we get negative x plus 8. So far so good. Let's see. I think as my next step, I'm going to try to create a problem where we'll need this rule. So I'm going to subtract 2x from both sides of this inequality, and I end up with negative 4 is less than or equal to, we have negative 3x plus 8. Okay, I'll now subtract 8 from both sides, and I have negative 12 is less than or equal to negative 3x. And I'm at my last step. I have to divide both sides by, it has to be negative 3. And this is where I need to be very careful, because on the left side you do get 4, on the right side you do get x, but you have to write this now as greater than or equal to. And that's because it started out less than, and now it has to be greater than. So as an interval of numbers, this is the same thing as saying, okay, well, if x is less than or equal to 4, that's everything from negative infinity up to and including 4. So everything to the left of 4, which matches up with the answer that we got in example 1. So everything else should be the same as working with an equation with this one detail. And for the final example, I would like to find all values of x that make this inequality true. This one's just a little bit more complicated, but let's see. To solve this for x, I'm going to start by simplifying both the left and the right side. So I see I have to distribute a negative into the parentheses. Here I have a negative 4, and we end up with negative 4x minus 1 minus x minus 25. Where is this greater than? I'm noticing that there's no equal sign here, but I think it's going to work the same way. On the right, we have 5x. We get minus 4x minus 20. So everything's now multiplied out, and I can start combining some like terms. On the left, we have negative 5x minus 26. Still is greater than. And then we have x minus 20. Okay, I think now I'm going to subtract x from both sides, but also add 26. And I end up with negative 6x is greater than, and on the right we have positive 6. So when I go to solve this for x, I'll divide both sides by negative 6. I know that means the answer is going to be x on the left, negative 1 on the right, but this time it's going to be less than, and that's because this changed directions due to dividing both sides by a negative number.